Students, let us solve a problem on fixed fastener assembly in this session. Plate 1 and plate 2 are to be fastened together using two numbers of M12 bolts. We have to calculate the maximum permissible values of position tolerances applicable at MMC limit to locate the holes on each of the two plates. So this is the problem. We have to find out the position tolerances for locating the holes on both the plates. Plate 1 has clearance hole. Plate 2 has threaded hole. Plate 1 drawing is shown here. This is the front view and the top view of the plate 1. The clearance holes are drilled to a size of 12.5 H8 on plate 1. The holes are positioned with reference to the datum C and datum B as shown here. We have to find out what is the maximum permissible value of position tolerance for locating the holes on plate 1. Plate 2 drawing is shown here. This is the front view. This is the top view of plate 2. Plate 2 has two threaded holes of size M12 with a pitch of 1.75 with a tolerance of 6H. The threaded holes are assigned with a projected tolerance of 18 mm. Since the plate 1 having a thickness of 18 mm is to be placed on plate 2, a projected tolerance zone of height equal to the thickness of the plate A, which is nothing but 18 mm, is applied to the holes on plate 2. We need to find out what is the maximum permissible value of position tolerance to locate the threaded hole on plate 2. So since this is a fixed fastener assembly, the applicable formula is for a fixed fastener with the use of projected tolerance zone. So this drawing is drawn with the projected tolerance zone. So the applicable formula is T1 plus T2 is equal to H minus F. If you want to consider a working clearance, then T1 plus T2 plus working clearance is equal to H minus F. Now let us solve for the T1, T2 value by using this formula. T1 plus T2 is equal to H minus F. So T1 is the tolerance to be applied on plate 1. T2 is the tolerance to be applied on plate 2, which has threaded holes. So sum of these two should be equal to H minus F. H is the MMC size of the clearance hole. So these holes are drilled to a size of 12.5 H8. The MMC size of the clearance hole is 12.5. So substituting a value of 12.5, then we have to find F value. F is the MMC size of the fastener. Now these two plates are fastened together using two number of M12 bolt. So the M12 bolt has a maximum size of 12 mm, which is the MMC size. So F value is 12 mm for this problem. So sum of T1 and T2 should be 0.5. So T1 plus T2 is 0.5. We can assign the value of T1 T2 either equally or unequally. If you want to assign equally, then okay, T1 can be assigned with 0.25, T2 can be assigned with 0.25. So 0.25 plus 0.25 equal to 0.5. If you want to assign more tolerance to the threaded hole, which may be more difficult to manufacture, then we can assign more tolerance to T2 and less tolerance to T1, but sum of the T1 and T2 should not be more than 0.5. So let us assign more value to the threaded hole position. So 0.2 plus 0.3 is equal to 0.5. So T1 is assigned with a value of 0.2. So the clearance hole on plate 1 is to be located with a position tolerance of 0.2 applicable at MMC. The threaded hole on plate 2 are to be located with a tolerance of 0.3 applicable at MMC. So the sum of T1 T2 should not exceed 0.5. For the same fixed fastener assembly problem, if you want to consider a working clearance of 0.02 mm, then the applicable formula is T1 plus T2 plus working clearance is equal to H minus F. So on applying this formula, we can find the value of T1 and T2. So T1 plus T2 plus 0.02 is equal to 12.5 minus 12. So the sum of T1 and T2 should not exceed 0.48. We can either assign equal or unequal tolerances to T1 T2, but the sum should not exceed 0.48.